All right, so this is where we left off in our previous video. So, like I was saying, there's some situations where problems are continuous. So, for example, bacteria is growing continuously, or maybe we have radioactive decay, right? So we have to model them a little differently. So there's a number here, E, that is used a lot. So you're going to be using E a lot. It's used in chemistry, especially if you're using uh, um, uh, rates and orders, like if something is order 1, order 0, right? You see them a lot. So this E is very similar to pi. You know, pi is approximately equal to 3.14. Well, this E, exponential E, is approximately 2.71. So if you want to know what the more numbers are, here is E. So it's super duper important. Make sure that you know what E is. Okay. So let's go ahead and see where E really came from. So where exactly did this number really come from? So what we're going to do is we're going to use a very popular formula used in finance to calculate compound interest. So if you have interest being compounded, so we see sometimes credit cards, you kind of have a monthly compounding, right? So you add interest every month. So you have some APR. That APR is divided by 12, and every month you get percentage of that APR. But sometimes there might be quarterly, sometimes it might be like semi-annual compounding. So there's a lot of different ways that it can do it. So this is a formula. This formula is from finance. Here, A is the ending amount. Okay, so how much money, like if you put money in a bank, how much money you have at the end. P is what we call the principal value, so how much money you're putting in the bank. R is an interest rate, so it's usually an annual interest rate. We call it sometimes APR. N is the number of compounding. So for example, if you're charging, if interest is being added every year, then you're just going to have whatever that R is. If you have interest that's being added every month, then it's going to be compounded 12 times. So compoundings, remember that's just how much interest is being added to your principal value. So if n equals 1, that means that the interest is annual. If n equals 2, that means that the interest is semi-annual. If n equals 4, that means that the interest is being compounded quarterly. N equals 12, that means that the interest is being compounded monthly. If n equals, I don't know, 365, that means that the interest rate is being compounded daily. Okay, and so on and so forth. There's other type of compoundings, but this is usually the typical ones. And that's basically what this value of n kind of stands for. And then T is the total number of years. So how much money for how long do you leave money in the bank? So in order to kind of discover this value of E, let's say we're putting $1 into the savings account. So here's our savings account. And we're going to put $1 in here. And what we're going to do is we're going to do this at an interest rate of 100% for 1 year. So we're going to do it for 1 year. And my interest rate is going to be at 100%, which is totally not believable, but we're just going to pretend it is. And what we're going to do is we're going to compound interest. So we're going to keep adding interest for many different values of n. So first I'm going to compound interest yearly. So if, let's say I only add interest, this 100% only once. So at the end of the year, I'm only going to get $2. Okay, so it's basically doubled. Now, what happens if I do it semi-annually? So I only add interest twice. Well, now I got a little bit more money, 2.25. Okay. What about if I add interest 4 times? Okay. So now you're going to have at $2.44. Okay. And you keep doing this over and over and over again. And then you do it every daily, every hour, every minute, every second. You just keep doing it over and over and over again. And what happens is that you don't get an infinite amount of money. What actually ends up happening is that you get closer and closer to this particular number, 2.71828, so on and so forth. And that number has a name. We call it E, Euler's number, okay? So in other words, as I keep compounding this value, we don't get an infinite number of of money. So it actually ends up going off, flattening off at a particular value. And this value, or this asymptote, is E. Okay, so it gets closer and closer to E. All right, so that's kind of where this number kind of was discovered. So what we're going to do is that if some phenomenon is described continuously, what we can do is we can rearrange this formula. So this formula doesn't really work for us. So if we keep doing it, if we let n go to infinity, then this formula, we can rewrite it. We can replace this guy. Instead of the n's, we're going to just write E. A is equal to P-E-K-T. And sometimes you might have seen it as A is equal to P-E-R-T. So A equals PERT. So you can see P-E-K-T or P-E-R-T. So R or K, so we can have R or K. This is going to be the rate, the growth rate. E is just a value that you can just plug into your calculator. So if you go to your TI-36X Pro, your E is the third button on the first column. What you're going to see is this E to the little box, and then you're going to see a 10 to the box. That button in your TI-36, if you have the TI-36X Pro, you're going to see the E button, okay? P is the initial amount, and K is the continuous rate, and T is the time. Okay, so if you have a phenomenon that is continuous, all right, so this is the key word, this key word, then you're going to use this formula. Okay, so let's go ahead and do an example. So here we have a petri dish starts off with 500 bacteria, and it's growing continuously at a rate of 4.5% per minute. How many bacteria will be in the petri dish in 1 hour? So you can see that this is growing continuously. Okay, so this means that I should use the formula A equals P-E to the KT. Right? My growth rate is 4.5% per minute. So that means that K is going to be 0.045. I start off with 500 bacteria. So that means that's P, that's the initial amount. That's 500. We want to know how many bacteria will be in 1 hour. Now be very careful with the units because this was minutes and now it's hours. So that's going to be a really easy way to do it because in 1 hour there are 60 minutes. So I'm just going to write 60 minutes here. So all we really got to do is just plug and chug. So A is equal to P is 500. E to the power of K, which is 0.045. And then T in this case will be 60. So let's plug this into our calculator, 500 E to the power of 0.045 times 60. And this is going to give me about 7,440 bacteria. So I started off with 500. It's exponentially, it's continuously growing. So in the end, after 1 hour, this is how many bacteria I will have. Okay? All right, so that's it for that one. In class on Thursday, we will do graphing. So you are off the hook on graphing. We will do this on Thursday.